15 Steps on How to Make Plastic from Seaweeds. Today, we're exploring a groundbreaking development in sustainable materials, making plastic from seaweed. In this episode, we'll explore the fascinating process of transforming seaweed into biodegradable plastic. We'll examine the steps involved, the technology used, and the potential benefits and challenges of this eco-friendly alternative. Join us as we uncover how seaweed-based plastics could revolutionize the packaging industry and contribute to a greener planet. 1. Seaweed cultivation. Seaweed cultivation, also known as seaweed farming, is a sustainable and eco-friendly agricultural practice that harnesses the natural growth cycles of various seaweed species. The process begins with selecting the appropriate type of seaweed, typically brown seaweeds such as bladderwrack or kelp, known for their high polysaccharide content, particularly alginate, which is crucial for plastic production. Farmers obtain seaweed seedlings or spores from mature seaweed plants. These seedlings are then attached to ropes, nets, or bamboo rafts submerged in the ocean. The choice of location for these farms is critical. They must have adequate sunlight, nutrient-rich waters, and minimal pollution. Seaweed farms require no fertilizers, fresh water, or arable land, making them a highly sustainable option. They also provide environmental benefits, such as carbon sequestration, water purification, and habitat creation for marine life. The seaweed snowballs, often reaching maturity within 45 days. During this period, the seaweed absorbs nutrients directly from seawater, which supports its fast growth and high yield. This rapid growth cycle allows for multiple harvests per year, increasing the productivity and profitability of seaweed farms. Farmers regularly monitor the growth and health of the seaweed, adjusting the position of the rafts to optimize exposure to sunlight and nutrients. 2. Harvesting. Harvesting seaweed involves carefully cutting the mature plants from the rafts while ensuring that enough of the plant remains attached to facilitate regrowth. This sustainable harvesting method allows for continuous production cycles, reducing the environmental impact and maintaining the health of the marine ecosystem. Harvesting is typically done manually, although mechanized systems can also be used, especially for more extensive operations. The harvested seaweed is then transported to the shore, where it undergoes an initial inspection to remove any apparent contaminants, such as debris or unwanted marine organisms. 3. Drying. Once harvested, the seaweed needs to be dried to reduce its moisture content, making it easier to transport and process. The drying process involves spreading the seaweed out in large, open areas under the sun. Depending on the climate and weather conditions, drying can take anywhere from 24 to 48 hours. In regions with less consistent sunlight, artificial drying methods, such as using drying chambers or dehydrators, may be employed. Sun drying is preferred due to its low energy consumption and environmental impact. During the drying process, the seaweed shrinks and becomes lighter, making it more manageable for subsequent handling. It's crucial to ensure even drying to prevent mold growth and preserve the quality of the seaweed. 4. Cleaning. After drying, the seaweed must be thoroughly cleaned to remove any remaining impurities. This process involves several steps to ensure that the final product is free from contaminants such as sand, salt, and other marine debris. The cleaning process typically includes rinsing. The dried seaweed is rinsed with clean water to remove surface dirt and salt. Sorting. The seaweed is manually or mechanically sorted to remove any unwanted materials, such as stones or shells. Scrubbing. In some cases, gentle scrubbing is performed to dislodge any stubborn contaminants clinging to the seaweed. Thoroughly cleaning the seaweed is essential for maintaining the purity of the extracted polysaccharides and ensuring the quality of the final plastic product. 5. Milling. Milling clean, dried seaweed involves grinding it into a fine powder. This step is crucial because it increases the seaweed's surface area, which facilitates the extraction of valuable polysaccharides. The milling process can be performed using various types of equipment, such as hammer mills, ball mills, or pin mills. The milled seaweed powder should be fine and uniform, ensuring consistent extraction and processing in the subsequent steps. The fineness of the powder can be controlled by adjusting the settings of the milling equipment. equipment. Proper milling not only improves the efficiency of extraction but also enhances the quality of the final plastic product by ensuring uniformity and consistency. 6. Extraction. The extraction process is where the polysaccharides, particularly alginate, are extracted from the milled seaweed powder. This process involves mixing the seaweed powder with water and heating it in a reactor. The heat helps to break down the cell walls of the seaweed, releasing the polysaccharides into the water. The extraction process typically involves the following steps. Hydration. The milled seaweed powder is mixed with a specific amount of water to form a slurry. Heating. The slurry is heated to a controlled temperature to facilitate the extraction of polysaccharides. The temperature and duration of heating can vary depending on the type of seaweed and the desired properties of the extract. pH adjustment. In some cases, the pH of the mixture is adjusted using acids or bases to optimize the extraction process. Agitation. The mixture is continuously stirred to ensure even heating and maximize the extraction of polysaccharides. 7. Filtration. After extraction, the mixture contains both the desired polysaccharides and solid residues from the seaweed. Filtration is used to separate the polysaccharide-rich solution from the solid residues. The filtration process can involve multiple stages, including coarse filtration. The mixture is passed through a coarse filter to remove large solid particles. Fine filtration. The remaining solution is then passed through finer filters to remove smaller particles and impurities, ensuring a smooth and homogeneous polysaccharide solution. Filtration is crucial for obtaining a high-quality extract that is free from contaminants, which is essential for producing consistent and reliable plastic materials. 8. Concentration. The filtered polysaccharide solution is typically quite dilute, so it needs to be concentrated to achieve the desired consistency for further processing. This is done using a rotary evaporator, a device that removes excess water from the solution through evaporation. The rotary evaporator works by heating the solution in a rotating flask, which increases the surface area for evaporation and reduces the pressure, allowing water to evaporate at a lower temperature. This method is efficient and helps preserve the integrity of the polysaccharides. Concentrating the solution to the right consistency is critical for achieving the desired properties in the final plastic product, such as flexibility, strength, and durability. 9. Solvent addition. To further refine the properties of the concentrated polysaccharide gel, specific solvents are added. These solvents help adjust the viscosity, elasticity, and other characteristics of the gel, making it suitable for forming plastic-like films. The choice of solvents depends on the desired properties of the final product, which can include organic solvents, plasticizers, and other additives. The solvents are carefully measured and mixed into the gel, ensuring even distribution and optimal modification of the gel's properties. 10. Casting. The modified polysaccharide gel is then cast into molds or spread onto flat surfaces to form thin films. This step determines the shape and thickness of the final plastic product. Casting can be performed using various methods, such as molding, pouring the gel into pre-designed molds to create specific shapes and forms. Flat casting, spreading the gel onto flat surfaces, such as glass or metal plates, to create uniform thin films. The thickness of the films can be controlled by adjusting the amount of gel used and the casting technique. Proper casting ensures that the final product has the desired dimensions and properties for its intended use. 11. Drying and curing. After casting, the films need to undergo drying and curing to remove any remaining moisture and set the final properties of the plastic. Drying can be done in several ways. Air drying, allowing the films to dry naturally in a controlled environment. Oven drying, using ovens to speed up the drying process. Dehumidification, using dehumidifiers to remove moisture from the air, accelerating the drying process. Curing involves allowing the films to rest and stabilize, which helps to set their final properties, such as flexibility, strength, and durability. Depending on the thickness of the films and environmental conditions, the drying and curing process can take several hours to days. 12. Cutting and shaping. Once dried and cured, the seaweed-based plastic films can be cut and shaped into the desired forms. This step can involve various techniques, including cutting, using precision cutters or lasers to cut the films into specific shapes and sizes; stamping, using molds and presses to stamp out shapes from the films; thermoforming, heating the films and forming them into three-dimensional shapes using molds and vacuum forming techniques. Proper cutting and shaping ensure that the final products meet the required specifications and are suitable for their intended applications. 13. Heat sealing. Seaweed-based films can be heat-sealed to create packaging solutions. Heat sealing involves using heat to bond the edges of the film together, forming airtight and leak-proof containers. This step is crucial for developing functional packaging products, such as bags, pouches, and wrappers. The heat sealing process typically involves heat application, applying heat to the edges of the film using a heat sealer; pressure application, applying pressure to ensure a robust and uniform seal; cooling, allowing the sealed area to cool and solidify, forming a solid bond. Proper heat sealing ensures that the packaging is secure and durable, suitable for protecting the contents and extending their shelf life. 14. Testing and quality control. The final seaweed-based plastic products undergo rigorous testing to ensure they meet the required standards for strength, durability, and biodegradability. Quality control involves mechanical testing, assessing the strength, flexibility, and durability of the films using tensile tests, puncture resistance tests, and other mechanical tests. Biodegradability testing, evaluating the rate at which the films break down in various environments, such as soil, compost, and seawater. Chemical testing, analyzing the chemical composition of the films to ensure they are free from harmful substances and meet safety standards. Quality control is essential to ensure that the products perform well and are safe for their intended uses, providing confidence to consumers and manufacturers. 15. Packaging and distribution. Detailed explanation. The finished seaweed-based plastic products are then packaged and prepared for distribution. Packaging involves protective packaging, using eco-friendly materials to protect the products during transport and storage; labeling, providing information on the packaging about the product, its properties, and its environmental benefits; bulk packaging, grouping products into larger packages for efficient transport and distribution. The packaged products are then distributed to various markets, including food packaging, shopping bags, gift wraps, fashion packaging, and more. The eco-friendly nature of these products makes them highly desirable in markets aiming to reduce plastic pollution and promote sustainability. By following these extensive steps, seaweed is transformed into a versatile and sustainable alternative to traditional plastics, addressing one of the world's most pressing environmental challenges. Thank you for watching this episode of BIZNOB, where we explored the innovative process of making plastic from seaweed. We hope you gained valuable insights into how this sustainable solution could impact the future of materials and reduce our reliance on traditional plastics. Don't forget to subscribe to our channel and hit the notification bell to stay updated with our latest videos. For more behind-the-scenes looks at innovative business practices and products, keep watching BIZNOB. Thank you for joining us, and see you in the next episode.